Well, I guess technically I've always had 2 iPads. Not always, but I just got it working. It's really old, so it was like not, I had to update and do all that fun stuff. But anyways, anywhoodle, here we are. That's way better, I think, than from my phone.
Yeah, that's good.
Can I get a what? Exactly. Sorry, there's a little echo, but it's because I don't know how to mute this thing. All right. It's gonna get old real quick. 14. 02. All right. So, last day of new material, review day next day, right? And then the test on Thursday. And then Thanksgiving, so you'll be all done. Yeah.
So we have the class test and then the online.
Yeah, so the assignment is due on Tuesday at midnight. Yeah, and that's the Moodle assignment. You take one, pass it down. Take one, pass it down.
I am going to bucket the notes on the
What? What's up? Thursday. Okay. So does anyone not have a formula sheet? I have a couple left. Formula sheet. Great.
Oh, I'm only missing half on the 11th. I'm only going to plug you for the 11th.
So those things are making their way around. Okay. What I've decided to do is to force you to practice for the review day. You're gonna, well, I don't have a copy here, I guess. Well, here. You're gonna go through and do the practice test on your own before Tuesday. Okay. And then at the beginning of class on Tuesday, you're gonna show me your work for 1 completion mark, which will count as an assignment. How's that for easy marks? Nice. So make sure you do that, right? If you don't show me anything, yeah, I can't give you marks, right? Yeah, so it's due on the 2nd. You bring it to class, and then in the review class, we'll go through it together, right? And that way you'll catch where things went wrong, if anything, or you can walk out feeling really good about yourself, right? Cool. And then you can ask questions about, right? Because it's just completion marks, so.
So on the review day, we'll go over this.
Yeah. And where are the extras here for the practice?
Yes. What are you looking at?
Great. So make sure you do these questions and bring them on. Bring them on Tuesday. All right. So let's do a little bit of review. What I want to do, right, is just go back to your formula sheet because it's going to be so important that we figure out what all these variables, right, all these letters mean. We're just going to go through and do a list of them together again, okay, just to emphasize what's going on. We haven't covered it yet, so.
Oh, is that what we're doing now, or are we doing Cvp?
We're trying.
Oh, I'm sorry. I was so confused.
So, let's see if I can.
Rate of Markdown. Yay!
Do the practice test for Tuesday. And show me your work at the beginning of class for completion marks. All right, too chatty back there. All right, reasonable enough, I think. Okay. So let's do a little bit of review. I really wish I could turn this thing off. I don't know. So just going through the formula sheet, right? Just kind of going through all these letters. Let's talk about what these all are, right? So we said N is the net price, right? So if it's the retailer, so the net price at each level of the distribution chain, right? So it's the price at each level of the distribution chain. Okay. And then we talked about L, capital L, is the list price. The list price is the suggested retail price. It's not necessarily the selling price, right? Because if I run a store and I need to bring in more money than that, right, I have to up the price, right? And so the list price is just the suggested retail price. And then going on, we have D, lowercase d, is the trade discount, right? So the trade discount at each level of the distribution chain. Okay. So we dealt with that last day. Capital S is the selling price. This is what the retailer actually sells it for. What the retailer actually sells an item for. And then we have C, which is the per unit cost. And then we said that at the retailer level, right, so at the final stage of the distribution chain, right, C, the per unit cost to acquire this thing is the same as the net price. Right? So for a retailer, C is going to be the same as N. Right? That's only true if you're talking at the same level of the distribution chain, which we most likely will be. Okay. So then we had M, which is the markup. Okay. We need to keep in mind that this is the amount of the markup, so a dollar amount. So amount of markup. Because then we talked about the ROMU, right, the rate of the markup. Okay. But we'll get there. The markup was made up of two things. So E, which is your, I'll just say expenses, right? Your overhead expenses, just the costs of running a store or having employees or whatever, right? And then capital P is your profit, which we all kind of know and love. And then we talked about the ROMU, which is the rate of the markup, and the GPM, which is the gross profit margin. And we have two formulas for calculating these things. And it just depends on the information that we have, right? And we went through an example where we had to calculate the ROMU and the GPM, but the ROMU only had, I guess, the markup, the amount of the markup and the cost, right? And so that's the formula that we had to use. And then to find the GPM, we could use either of the formulas. Right? So we went through an example like that. Call that the end of the review. So what we didn't get to last day was markdowns, right? We can have markups, or if something goes on sale, we have markdowns. Right? So markdowns is a reduction in the selling price of an item. A reduction in the selling price of an item. Okay. So when we're talking about markdowns, we have to establish even more terminology. It's all terminology. All right, so we're going to let capital D be the amount of the markdown. Okay. So just like M was the amount of the markup, right? Capital D is the amount of the markdown. Okay. And then we have our old friend S, which is the regular selling price now. And we're going to have a reduced selling price. So capital S and then subscript R, lowercase r, is the reduced selling price. So then we can find the rate of the markdown. So the rate of the markdown is the ROMD. ROMD. ROMdown. ROMD. And similar to the rate of the markup, right? It's some function of the markup or the markdown. So it's the amount of the markdown over the original selling price. Okay. So the rate of the markdown is some percentage of the original selling price, right? 30% off, 20% off, that kind of thing. Okay. And we can find that the reduced selling price takes kind of the same shape as the net price, right? So we have the net price is the list price times 1 minus the discount, right? So now the reduced selling price is the original selling price times 1 minus the discount, which is your ROMD. Okay. Yeah, thanks, Pat. Let's do an example. We'll do example 96. Where is it? Here. So example 96, in case it's too small, The sign on a rack of sport coats reads, all prices marked down 30%. What's the regular selling price of a coat marked at $100 and be $196.49? So what's understood here is because we're asking what is the regular selling price, even though it's not obvious, right? We assume that they've already been marked down to $100 and to $196.49. Okay? So sometimes we have to read this question and say, oh, well, these prices must be the reduced selling price. So for part A, we're told that the rate of the markdown, right? Because 30% off, that's a rate, right? That's not an amount. So the rate of the markdown is 30% or 0.30. And for part A, the reduced selling price is 100. From our formulas, right, on your formula sheet, you have the reduced selling price is S times 1 minus the rate of the markdown. I'll just make a note here that we have to find S. Huh. Hopefully it'll hang in there. Okay, so our reduced selling price we said was 100, and we're trying to solve for S. We've done this before, right? Very similar. 1 minus 0.30. Don't forget that 1 minus, right? It's going to make a big difference. So you get 100 is 0.70S. Kind of simplifying things. So then S must be 100 divided by 0.7. And I'll steal it from here. I have 142, but I think I rounded my decimals already. So let me see, where's my calculator? 100 divided by 0.7, 142, just so you can check your decimal places, right? 142.8571429. So the original selling price, oops, is $142.86. Right. When we're talking money, you'll automatically know to round to 2 decimal places. Okay. Cool. So same idea, right? A little bit tedious, but just to feel good, let's do part B, right? Same idea. The rate of the markdown is still 0.3. And now the reduced selling price is $196.49. Exact same question, right? Different numbers. So we know now the reduced selling price is S times 1 minus the rate of the markdown. The reduced selling price in this case is $196.49, which is S times, we can even skip a little. No, we shouldn't do that. 1 minus 0.30. I was tempted. 196.49 is 0.70 S. So S must be 196.49 divided by 0.70. 196.49 divided by 0.7. 2.80 even. Cool. So I'll just leave it at that. Any questions about that? Yeah. So that wraps up our merchandising section on our formula sheet. Right? That's a lot of formulas that we've gone through, but feels like we've got a pretty good handle on them. Right? So now we're going to move into what we call CVP analysis. And I can never remember, it's cost, value, price, or profit. I can never keep track. That's your guys' job. You guys know. It's business. Okay. So essentially what we're going to be doing is we're going to be developing a profit function. Right, earlier I was just giving it to you. Here's a profit function. Now we're going to learn how we build up these profit functions. Okay. Oh, this is old. I need this. All right. So 3.3 is vaguely called business economics. I guess it is. Profit functions. Doesn't get more business economics than that. Oh. It's a little laggy. Economics. Okay. Nice. Maybe it's just needs some time. What the?
Oh. Well, okay then.
It's because I said something. It seems to know that we're all here, even though it looks like I don't have any internet. Oh, no, I do actually. So I'm not sure what's going on there. Okay. Hands free. I didn't do a thing. Weird. Okay. Well, let's keep going. So looking at our formula sheet, right, this second section, it's way shorter, but there are a few variables that we need to define, right, so we can talk about them freely. Okay, so we're going to do that. What's nice, right, is that test one is only going to be on these first two sections of your formula sheet, right? And so, and then we can move on. And if you just have a glance at your formula sheet, things start getting a little bit more cohesive after this, right? Simple interest moving into compound interest, and then moving into annuities towards the end. Right? And so everything just kind of flows. Okay? So, all right, let's start at the top. We're going to define our fixed costs. Hello. Okay. So the fixed cost is exactly what you think it is. All right. A fixed cost is just a cost that you have that's independent of the output that you're producing. Okay. So it's independent of the amount of output. So things like rent, right? You're not paying rent based off of how much you're selling or producing, right? You're just paying a fixed amount of rent, your cell phone bills, etc. Right? And then, of course, we have our variable costs. Which vary. I almost said varies, but I decided on singular, sort of. Vary with the amount of output. This echo is so annoying. Yeah, it's making me think of downsizing again. It's like this little.
Just turn it down on your iPad on both of them.
Is that what's going on?
Yeah, just turn it down.
The only new one is this one, and I've turned it down completely. This one I've never touched. I don't know. Oh, here we go. Let's see if that's better.
Yeah,
I'm still there.
but not nearly as audible.
Hopefully it works.
You know the microphone up at the very top?
Mm-hmm.
Press that.
Do you mean this one?
Okay, that one's me. Try on the other laptop.
Well, because it's recording my voice, I don't want to mute myself.
That's
That's
weird that it's recording your voice and giving it back to you. Though.
that's the pickle, right? And I can just sit here.
Yeah, then you didn't hear.
Oh, that's
No,
clever.
that would work.
Yeah, you're right.
I can just sling it over my shoulder. We've got options. I'll work on it over the weekend. Anyways, variable costs. Anyways, so they vary with the amount of output, of course. So materials, labor, right? Those sorts of things. And together they make up your TC, your total costs. And we're told on our formula sheet that TC is the variable cost plus the fixed costs. I forgot to box in the formulas from earlier. There's only two. I'll scroll up and do it for these guys. The rate of the markdown is on your formula sheet, and the reduced selling price is, of course, on your formula sheet. There. Bless you. Whey. Okay. Whey. Yeah. Okay. So, we're gonna let. I'm only hesitating because yesterday I thought, oh, I should do that in a different order, but now I can't remember what it was. So, anyways, I'll just do it the same order as in my notes. Oh, we don't need a let. We're letting everything be here. Lowercase x is going to be the number of units produced or sold, depending on the context. Okay. So x is the number of units produced or sold, depending on the context. And we're going to let capital C be the cost to produce 1 unit. Okay. We've already seen a capital C, but this one's different, right? So it depends on the question that you're dealing with. It is the per unit cost, right? The cost to acquire a unit. So technically they're the same, right? But the contexts are going to be different. So C is the cost to produce 1 unit. Okay. So what we can say is that the variable cost is C times X, right? The cost per unit, which takes into account everything like materials and labor and I don't know, whatever you can think of, times however many units you're producing. Okay. So that's on your formula sheet. We can talk about the price, lowercase p, think this is what I wanted to do. This is the price at which you're selling this item, right? So it's not a capital P, it's not the profit, right? It's just how much are you selling each item for, okay? So the price at which each item is sold, lowercase p. Okay. Our total revenue, that's a biggie, right? TR. Total revenue is before you've deducted all your costs, right? It's just how many items did you sell times however much you charged per item, right? That's your total revenue. And then you have to deduct your costs. Okay? So it's the total revenue brought in from sales. So what we're really saying is that the total revenue is P times X, right? It's the price per unit times however many units we've sold. Also on our formula sheet. We're crushing these. So then our profit, right? That's going to be the difference between our total revenue that we bring in, and once we've deducted all our costs, right? That's our profit. Okay. So our profit is the difference between the total revenue and the total cost. Which leads us to the profit of X, right? Because the amount of profit that we make depends on how many units we've sold, right? Or produced, right? Usually sold. The profit of X in its bare bones is going to be the total revenue minus the total cost, which is the last item on your formula sheet in this section. Right, so that's not so bad. Okay, so now notice that we can kind of substitute all these formulas into the profit function and expand it. All right, so let's do that. So knowing that the profit of X is the total revenue minus the total costs, we can expand this to find a general profit function. To find a general profit function. Now, what you'll notice is that what we're going to derive here isn't on the formula sheet, right? But if you derive it at one point on your tests or your assignments or whatever you're doing, then you can use it throughout, right? You have to show me how you got there once, and then you can just use it, okay? Which might come in handy, as you'll see. So we're saying, and we've seen a profit function like this before, profit of X. I'm deriving the formula. So the profit of X in its bare bones is the total revenue minus the total cost. But then looking at our formula sheet, right, we can replace the total revenue by P times X. And I'll do one replacement at each step. So we have P times X minus the total cost. You can do these in a single step if you want. So then we have P times X, can't be simplified any further, but TC, the total cost, we can replace it with the variable cost plus the fixed cost from our formula sheet. And then we have a formula for the variable cost. So we can sneak that in. Remember to keep these brackets around the total cost, right? Because that adding in the middle there, if we leave the brackets, right, that's going to mess us up because we have to expand the negative into the brackets. So the variable cost we can replace with the cost per unit times however many units plus the fixed costs. And even though we have two capital C's, we know that these are different, right? One's the per unit cost and one's the fixed cost. So we can't collect those like terms, right? So that's why it's important to keep track of our variables. Right? Now we can expand and simplify, right? So we can bring that negative and break out the brackets. So we have PX minus CX minus the fixed cost. Now we can collect our like terms of X and say that X times P minus C minus the fixed cost. So this is probably the profit function that you'll want to work with, right? Bless you. Okay. But as long as, and like I said, as long as you show me how you found it once, there are a few extra steps in there, right? You don't have to show all those individual steps. You can do them all in once, right? But as long as you show me where it's coming from, then you're free to use it later on, which we'll see is handy. Any questions about that before we keep going? All right. So let's do example 100. Oops. So Alienware Computers sells computers for $1,000. Production costs for each computer total $250. Doesn't say each, but I'm telling you each. Rent for Alienware's office is $10,000 per month. Determine the monthly profit function for Alienware computers, and then compute the profit resulting from producing 12, 13, 14, and 15 units. We're not going to do all those because it's all the same, right? And use those to determine how many computers must be sold before Alienware makes a profit. We'll answer that one, but in a clever way. Okay. All right. Nothing to it but to do it, I guess. So we're given things here. So we're given the price at which each computer is sold is 1,000. Yeah, sorry.
What does can you define what profit function is? I'm not understanding.
Oh,
it says determine the monthly profit function.
Yeah, so the profit function we use to, and we plug in how many units we've sold, what did we sell them at, and then what's the cost to produce each unit, and then we subtract our fixed cost. So it's essentially just saying, taking everything into account to see how much profit you're actually making. Cool. So P, the price per computer that they're selling them at, is 1,000. Production costs for a computer, total $250. So the cost to produce each computer is capital C now, right? Which is $250. Okay. And we're told that the fixed costs, the only ones we're given is the rent, which is $10,000 per month. So we have to find the profit function. So find profit of X. Find the profit function. So just as a little bit of practice, I'm going to develop that general profit function again. So basically go through these steps, but cut out the unnecessary steps, right? So show you what I'm expecting to see. Okay. Yeah. So from our formula sheet, we have the profit of X is the total revenue minus the total cost. And just plugging things in right away, I know the total revenue is P times X minus, I'll do the variable costs next, but I'll just replace the total cost with the variable cost plus the fixed costs on the same line. Now I'm going to substitute my variable cost is actually C times X plus the fixed costs. Expand the brackets, so PX minus CX minus the fixed costs. Oh, because I'm ditching the bracket, so I'm bringing that negative inside. Yeah. So that's going to be important, right? Because we don't want to add our fixed costs to our profit. That would be a mess. So that's important. Good. And now we can collect like terms and say that X times P minus C minus our fixed costs. So our profit function is profit of X. I'll write out the general one that we just derived. X times P minus C minus the fixed cost. Just because I don't have it in me to just plug them all in right away. I have to write it out. It's a compulsion, I guess. So X we leave just on its own because we don't know X. We only know P and C and the fixed costs. And so, but we know P is 1,000 and C is 250. So P is 1,000, C is 250 minus our fixed costs of 10,000. Cool. So then, well, let's simplify this first, right? We get 750x minus 10,000. And then we're asked to find, compute the profit resulting from producing 12, 13, 14, and 15 units. I'm just going to do 12 and 14. We don't need to do it 4 times over. That's crazy. So I'm going to show that I'm using X equal to 12 by writing profit of 12. Is 750 times 12 minus 10,000. 750 times 12 is 9,000 minus 10,000. So I've got a profit of negative 1,000. All right, that's not that great. What if we find the profit of 14 computers? So 750 times 14 minus 10,000. 750 times 14. 10,500 minus 10,000. Woohoo! Now we have a positive profit of $500. So instead of calculating all these, right, where between 12 and 14 does it switch over to being a positive profit, right? That's essentially saying at what point does the profit go from negative to positive, meaning it crosses zero, right? So if I say, how many do we have to sell before we can make a positive profit? We can just let the profit be zero and solve for X, right? So just kind of a new question that's not on there. How many computers must we sell to make a positive profit? So how many do we need to sell to make more than $0? More than $0, right? So we know that the profit of X is 750X minus 10,000, right? So if I let the profit be 0, I can solve for the X that makes that happen, right? And then I just know that I need to produce even more than that, right? So let this be 0, 750X minus 10,000. Moving the 10,000 over to the right-hand side, right, I get 10,000 is 750X. So X is 10,000 divided by 750. 10,000 divided by 750. X must be 13.33 repeating. Which means we can't sell 0.33 repeating of a computer, right? We can either sell 13, which would have a negative profit still, right? Or we can go to 14, now we have a positive profit. So, which we know from earlier, we get $500 in profit. So we jump from making a negative profit to 500 in the next computer. Right? So since we can't sell 0.33 repeating of a computer, we would need to sell, oops, at least 14 computers for a positive profit. Cool. Same idea, right? If I said, okay, I want to make $20,000 in profit, how many do I need to sell? Okay. So how many computers do we need to sell to make $20,000 in profit? Okay. So just work through that one for a minute. So again, we know our profit of X, I'll just get started here, is 750X minus 10,000. Exact same idea, right? We replace the profit with 20,000. We're forcing the profit to be 20,000. And then solving for X, 750X minus 10,000. So again, we add 10,000 to both sides, so we get 30,000 is 750X. So X is 30,000 divided by 750. 30,000 divided by 750. A nice even 40 computers to make $20,000. So, right, there's kind of a jump, right? So we go from making negative profit, and then all of a sudden, once we sell 14, then now we're making profit. Right? Cool. Any questions about that one? All right, let's do another example. Example 103. It is, yeah. Yeah, so this is a monthly profit function that we developed. So here's a little thinker. I know you guys love those. Oh. No, all my classes love thinkers. If a company makes $2,000 in profit from selling 100 units and $10,000 profit from selling 150 units, what are the fixed costs? So we have the amount of profit and the number of units, right? We don't know how much each unit is selling for, and we don't know the amount it costs to produce each unit, right? But we can work around that. And then we need to find the fixed costs. Okay? So let's outline what we know and go from there. Right? That's always a good policy. So we're told that the profit of 100 units is $2,000. Okay? And we're also told that the profit of 150 units is $10,000. And we want to find the fixed costs. So this one's a thinker. There's lots of ways that we could solve it, right? I'll show you one of the ways, but all of them involve setting each of the equations equal to the same thing, and then using substitution, right? Setting them equal to each other and solving. So our profit function, now I'm going to go ahead and use that general one that we developed. So we said that in general, profit of X can be written as X times P minus C minus the fixed costs, just in general. Okay. All right. So then we're told that the profit of 100 as a fact is 2,000, which is the same as 100 times P minus C minus the fixed costs. Right? Just taking our information that we're given and just extending our general profit function. Because all we really know is that X is 100 and the profit is 2,000. And we also are given the same idea that the profit of 150 is 10,000. So X is 150 now times P minus C minus your fixed costs. This is like solving a system of equations. Right? We can call this 1 and this 2 if we want. Okay. And there's lots of ways that we could solve this, right? But usually what we like to do is we just like to set each of these equations equal to the same thing, right? So we could move the 2,000 over to the right and the 10,000 over to the right, making both left-hand sides 0, right? Or we could solve each of them for the fixed costs. I think I'll do that since we want to solve for the fixed costs later anyways. Right? Nice to have them in terms of the fixed costs anyways. So we will solve 1 and 2 for the fixed costs. So equation 1 becomes, we have 2,000 is 100 times P minus C minus the fixed costs. And in general, I don't want you to be afraid of leaving variables just as they are, right? You can pretend that P minus C is just its own thing, right? Just one thing that we have to move around. So P minus C can be X and FC can be Y. Then it doesn't look so bad, right? Yeah. So then we have solving for the fixed costs. I can add the fixed costs to the left-hand side and subtract the 2,000 from the right-hand side. So I have 100 times P minus C minus 2,000. I just did my switcheroo in one step. My second equation, same idea, 10,000 is 150 times P minus C minus the fixed costs. Again, moving my fixed cost to the left-hand side and my 10,000 to the right-hand side, I get the fixed costs is 150 times P minus C minus 10,000. Yeah, we're just solving for the fixed costs in each of these.
What about those like the 100 and the 2,000? We don't do anything with that?
No, they'll cancel out. But eventually, I guess. So now we have two equations for the fixed costs, right? The fixed costs for each of these are going to be the same because we're talking about the same production, right? The same factory, the same profit function. They each have the same fixed costs, right? And so we can set these equal to each other, right? So I'll write them as kind of a tandem thing, right? So equation 1 equals the fixed cost, which equals equation 2, right? Just to show that they're the same. So we have 100 times P minus C minus 2,000. That's the fixed costs. Right? I think we can all agree that I'm just rewriting what we found in equation 1 backwards. Right? But the fixed cost is also equal to 150 times P minus C minus 10,000. So we can cut out the middleman of the fixed costs, right? And that's the reason that we solved both of them for the fixed costs. Right? And so now we can say something like 100 times P minus C minus 2,000 is 150 times P minus C minus 10,000. So now, looking at P minus C as just one thing, right? We can collect like terms. So I'm gonna swing my 100 minus P or times P minus C over to the right-hand side and my 10,000 over to the left-hand side, only because I don't like negatives. They would cancel out eventually, right? But I just like to do what's easiest for me. Okay. So now we can say that, all right. I have negative 2,000 plus 10,000, showing this in one step. It's bold. 150 times P minus C minus 100 times P minus C. So now we have 8,000. Treating P minus C as just one thing, right? We have 150 P minus C minus 100 P minus C. So now we just have 50 P minus C. So regardless of what P and C are, we can solve for P minus C and find that we have P minus C is 8,000 divided by 50. I don't leave anything to chance. I calculate everything on my calculator. 160. So now we know that P minus C is 160, right? But our goal was to find the fixed costs. So you can use either of these equations that we found initially, right? The fixed cost, they're going to yield the same fixed cost, right?
So you just need to plug it into one.
Mm-hmm. So now, substitute P minus C equals 160 into 1 or 2, your choice. I'll do 1. The fixed cost is, I wonder if I have it here somewhere. No. 100 times P minus C minus 2,000. So my fixed cost then must be 100 times 160 minus 2,000. $16,000 minus 2,000. $14,000. And I think, is this the one where the textbook has a typo? Yeah. Because I'm very confident I did it right. And they're subtracting 8,000, which doesn't make sense. So textbook has a typo. But you're here, you heard it here first. I think it finds that it's 8,000 instead of 14,000. And it's because it's not minus 8,000 on the end, it's minus 2,000, or if we're using the first one. Cool, right? Yeah, cool. So let's talk about the shutdown point. So all productions have some shutdown point, right? Where we're better off just not producing anything at all, right? And it's actually not when we make a negative profit, right? Because there's going to be a point where we still have these fixed expenses, right, that we need to handle. So even if we're not making a positive profit, we're still taking off chunks of those fixed costs that we have, right? Because if we're not producing, we still have to pay rent, right? So it's better to produce maybe a little bit to kind of eat into those costs than not produce at all. But there is a point where we need to shut things down just because we actually are paying to produce things, right? So the shutdown point. Oops. I always combine them. Combine all my words. Shutdown point. is the point where a firm is better off not producing at all. Is better off not producing at all. So just when is that? It's when we can no longer cover our variable costs. So our fixed costs, they're fixed. We can't do anything about it, right? But essentially when we can't charge more than it costs to produce the thing, you need to shut it down, right? And so if you can no longer cover your variable costs, you've reached the shutdown point. Oops. You have reached the shutdown point. In terms of the general profit function, right, we have the profit of X is X times P minus C minus the fixed costs, right? Where C is our variable costs. Right, that's the cost per unit. So what we're saying by the shutdown point is that if this value, P minus C, is less than 0, meaning the price that we're charging for the thing is actually less than it costs to produce it, right? That doesn't make sense. So we would shut it down. So if this value is less than 0, we have reached the shutdown point. We have reached the shutdown point. Exactly. Right, because then if we're thinking about P minus C as a negative number, then you have, making up your profit, you have a negative number working against you, right? Times however many units you're selling. And then you have to subtract your fixed costs. You'll never make a profit. In fact, you'll lose money a lot. Just as a little note, P minus C is called the contribution margin. I'll never call it that again. I just, in case you hear it come up, is called the contribution margin. Essentially, how much is each item contributing to your profit, right? So we're saying that the shutdown point mathematically is when P minus C is less than 0. Or when P is less than C. Cool. And I think intuitively that makes sense, right? If I tell you that it costs me $10 to produce something and I'm selling them for $7, you'd probably say you need to stop that right away, right? Right? You'd stop me, right? All right. Example 104. So here we're given a profit function. This looks familiar. Right. So a firm's profit is given by P minus 13 times X minus 75. At what market price does the firm shut down? So what's the shutdown point? And if the price is $1 above the shutdown point and the quantity produced is 10, how much profit is made? It's reasonable. Okay. So first we're going to find the shutdown point. The shutdown point is going to be when P minus 13 is less than 0. Right? Equal to is fine, because then we would just be even, right? So just less than. So then moving the 13 over to the right-hand side, because we can just treat them as an equal sign, P less than 13 is our shutdown point. Okay. So our shutdown point is any price lower than 13. It is too easy. So now let's amp it up a little bit. If the price, or not. No, let's amp it up. If the price is $1 above shutdown, okay, and the quantity produced is 10, right? How much profit are we making? So now, let P be 13 plus 1, because we said shutdown is 13, and now we're told that the price is the shutdown plus 1. Right? So 13 plus 1, I'll just write it out, it's 14. And X is going to be 10. So using the profit function that we've been given here, X I'm going to erase there and replace it with 10, profit of 10. Oh, because we were told, and the quantity produced is 10, how much profit is made?
Because X is the amount that we produced. I'm just not reading it.
So here, the quantity produced, oh, it's not. Of course not. Great. Right, so if the quantity produced is 10. Because X, remember, is the quantity produced or the quantity sold. Often we assume that the amount we produce is the amount that we're selling. We know that's not always the case, but it simplifies things. Right? Hopefully that does it. Great. So now we have the profit function, which was given to us as, I'll just copy it from here, P minus 13 times X minus 75. Right? We're told that P has to be 14 in this case, so 14 minus 13 times X, which is 10, minus 75. So now we have just 1 times 10 is 10, minus 75. So we're making a negative 65 profit. That doesn't sound good, right? But we know that it's higher than the shutdown point because it's eating into our fixed costs, right? It's taken 10 off of our fixed costs, right? Which we would have had to pay anyways. So even though it's a little counterintuitive, we don't like dealing with negative profits, right? But they happen for some amount of time until we reach our break-even point. Which we'll talk about in a second. Where are we here? Let's do another example. Example 106. So example 106, Labatt's Brewery spends 42 cents to brew a can of beer. Okay. The fixed costs associated with producing beer are $450,000. I don't know, per year, per month, per day, who knows? And it doesn't matter, right? As long as we're consistent. So the going price for a can of beer is $1.25. So the price they charge is $1.25. The cost to produce a beer is 42 cents. And then our fixed costs are the $450,000. Okay. So question 1, what's the profit function for Labatt's Brewery? Okay. So first, let's write out in general what we've been given here. Or I guess I should do them in order. I'm told that the costs to produce a can of beer is 0.42. And the fixed costs are 450,000. And the price that we sell a can of beer for is $1.25. Question 1, find the profit function. I'm going to go straight to that general profit function just because that's probably where you would be on the test, right? If this was your first profit function that you're dealing with on the test, you would develop that general formula so that you could use it. You can develop it every time, but that gets tedious. Right? So the profit of X is X times P minus C minus the fixed costs. Okay. So our profit function, we don't know X, and that's okay. P minus C, P is $1.25, minus C, which is 42 cents, minus our 450,000. Okay, so then $1.25 minus 0.42, we have 0.83x minus 450,000. So there's our profit function for the brewery.
We don't have to divide that.
Nope, that's the end of the road because that's just the profit function. Yeah. So yeah.
Sorry, on a test, are you gonna, or do you want us to develop the profit function like you just said, or can we just use the X?
You have to show that you can develop it once, right? And then you can use it. Yeah. So question 2. What's the profit earned by selling 10 million cans of beer? It's a lot of zeros coming up. So now X is going to be 10 million. It's a lot of beer. So the profit of 10 million, 1, 2, 3, 1, 2, 3, is 0.83 times 10 million minus 450,000. A lot of zeros. But I think you're gonna like the profit. So it might be worth it. So the 0.83 times 10 million, here we go. 1, 2, 3, 1, 2, 3. So we have 8,300,000 minus 450,000, making that 450,000 seem like chump change. 1, 2, 3. So we get a profit of 7,850,000. That's decent. It's like per day. No. I don't know. How long would it take to sell 10 million cans of beer? I don't know. Yeah, that's true. Yeah, they sell themselves. So question 3, what does the price need to drop to in order for Levesque to shut down production? We already kind of know this. There's really no math involved.
Less than.
So the shutdown point, right, is when from our general profit function, right, we had that P minus C, which is P minus 0.42, because we're trying to find the price where we shut it down. Where is it less than 0? Meaning that P less than 42 cents is our shutdown point. Really, if you just, or we can say something like this, or in words, say, since the cost to brew a can of beer, right, since the cost per beer is 0.42, our shutdown point is when P is less than 0.42. Right, so you can show it mathematically, or if it makes more sense to you, just say it in words. Yeah.
It says shutdown point is 42 cents. Would that be?
Yeah, that's okay. Either way. Yes. It's just that's where it transitions.
Okay.
Yeah. So we can be. I'm flexible. Yeah. I only like the less than because we know that P minus C has to be less than 0. So we have that less than, and then, yeah. But yeah, if you say the shutdown point is 42 cents, that's right too. Yeah.
Why are we not using the P?
Oh, because here we're saying, we're told that they're selling them at $1.25. The shutdown point is when we have to find at what price do we have to shut it down. So the price isn't $1.25 anymore, right? We're just saying what's our lowest price that we can possibly go to.
So this is new P.
Yeah. Yes. Cool. Any other questions about that one?
Why are these on the formula sheet? Like our basic profit function and the shutdown.
Because those are conceptual. So those are things that I need you to know, right? But I can't say it on a formula sheet because it's kind of like, well, reaching the shutdown point means that you know that that's when the price that you're able to charge is less than the cost to produce it. So that's why it's not on the formula sheet. And the general profit function, you have all the components to build it. Cool. Let's talk about the break-even output, right? Where we transition from negative profit to positive profit. We've already done it, right? So no big deal for us. The break-even output is the level of output where the profit is 0. Oops. So we've got the shutdown point where we shouldn't produce anything at all. And then we know, because we've talked about it, we know we make a negative profit for some amount of time. And then when we transition from negative to positive profit, that's our break-even output, right? The amount of units that we have to sell to transition from a negative to a positive profit, break even. Okay. So now let's do example 108. Oh, 109, 108. Things are a little crooked here. I couldn't get the page to lay flat when I took the picture. So this one's laid out a little bit differently, right? So suppose that the price of a good is $25 and the total costs are given by $85 plus 24 times X. What's the break-even level of output? Okay. So the price of a good, we're going to say, is the price that we're selling it at, right? Because if it was the cost to produce it, right, then we would have to say the price to produce a good. We would usually just say cost. Okay. So we know that P, the price, is $25. And the total cost is just told to us that it's 85 plus 24 times X. But looking at the setup of this, right, our fixed cost must be 85 and our variable cost must be 24 times X. Right, same setup. Okay. Let me make a note here. This must be our fixed cost and this must be our variable cost, right? Because our fixed cost is just going to be a number. Mm-hmm. And then our variable cost always has the X on it. Mm-hmm. Nice.
They're backwards. Yeah.
They are. It's allowed. All right, all right. So, because of the information that we're given, right, we're given that the total cost is just 85 plus 24 times X. So what we're going to do is we're just going to start from the bare bones profit function because we have TC already, right? So we're told that profit is the total revenue minus the total cost. That's probably the best place to start here. Instead of having to dissect the total cost for the fixed costs, variable costs, we can just use the total cost as it's given to us. The total revenue, right, is still P times X minus our total cost, which is 85 plus 24 times X. So even though we'll often want to use that general profit function that we keep developing, right, sometimes it's just easier to go from the bare bones on your formula sheet. So now we know that P is 25. We don't know X. And then we can expand these brackets and get negative 85 minus 24X. Collecting our like terms, right, we get 25X minus 24X. I'm just going to skip straight to x minus 85. And 25 minus 24 makes 1x minus 85.
Okay, I got it. Collected them.
So now to find the break-even point, set profit equal to 0, which we've done before, right? We started off our day like that, setting the profit equal to 0. How many computers do we need to sell to make a positive profit, right? So we've already done this, which is why it's a nice note to kind of finish on. So now we're saying that 0 must be x minus 85. So x must be 85. So we have to sell at least 85 whatevers to make a profit, a positive profit. How about example 109? This one got all wavy. Things got weird. Suppose it costs, it's got this like, woo. So suppose it costs $75 per minute to run a TV commercial during sporting events. Furthermore, you've determined that revenues from these TV commercials amounts to $125 per minute they air. So essentially, the cost to produce each minute is $75, and you sell it for $125, right, per minute. The total cost of creating a TV commercial is roughly $15,000. And we're supposed to understand that that's our fixed cost, right, the $15,000. How long do you have to run your commercial in order to break even? So it costs a little to make some. We've got this fixed cost of $15,000, which means if we're trying to find our break-even point, we have to have a profit function first. And then we set it equal to 0, solve for x. There you have it. So we're given that the cost per minute is 75. And the price that we sell it at per minute is 125. Sell, sort of. And the fixed costs, we're told, are 15,000. But we skip straight to our general profit function. We've developed it enough times now. X times P minus C minus the fixed cost. X times P is 125 minus C is 75 minus our fixed costs of 15,000. $125 minus 75, we get 50x minus 15,000. So now we set the profit. Set profit equal to 0. And solve for x.
Why can't we just divide that by 50 because the other side we find that?
Oh, yeah, because the whole goal was to find the profit function, which we've done. So now we have to find the break-even point.
Right, because this one, X on the right-hand side isn't the same as the profit.
That's right. Yeah, exactly. So now we have 0 is 50x minus 15,000. We can move the 15,000 over. Is 50x. So x is 15,000 divided by 50. X must be 300. So therefore,
Why does that, when you do like x times 125 minus 75, why does it move to the other side of it?
oh, just because I like it there. It doesn't matter. I just like to have the number and then the variable. Yeah. But on the other hand, if I have the x times p minus c, I like to have it on the left-hand side. So it's just a matter of what I like. It doesn't matter. So therefore, because this was kind of a word question, we're going to answer it with a sentence. Pardon? Yeah. Yeah. It's okay. Therefore, the commercial must run for at least 300 minutes, right, to break even.
So is it just part of showing your work that we can't just skip to that part?
Yeah. Mm-hmm. Unless you started up here and you said profit of x right at the beginning, you're forcing it to be 0 on the next line. So what you could do if you wanted to, you could say from here, write that there, and then you can skip, right? Yeah. I'll remove that. Any questions about that? So just a note for, yeah. Mm-hmm. It just depends on, I have important information, so don't leave yet. It just depends on what information you're given. So that's why I always start with outlining what we've been given. And then it's easier to say, okay, this means that I don't have these things, so I'm going to start at this point, for example. So it's just going to be a matter of practice, unfortunately. All right, here's the super important thing. Very important. We can't do question 4 on the practice test, which means question 4 is not on the actual test. So don't bother doing it. We ran out of time and whatever. So we can't do question 4 on the practice test. So it won't be on the test either. Okay. Any questions? All right. See you guys next week. And if you didn't get a practice test, make sure you grab one so that you can get the marks next day. See you later.